Now that we've talked about circles and parabolas, it's time to talk about ellipses. An ellipse is basically an oval, or an oval shape. By definition, an ellipse is the set of all points in a plane whose sum of the distances from 2 points inside, called the foci, call that foci 1 and foci 2, is equal. So if I have a point on the outside of the ellipse, the distance from the point to the first foci plus the distance, call that distance 1, plus distance 2 has to be equal to, if I pick this point over here and I find the distance from this point to this foci plus this point to this foci, which is going to be the same as if I were to pick this point on the outside of the ellipse and I find this distance and I find this distance and I add them. The sum of the two distances from the point to each foci will be equal no matter what point on the outside of the ellipse that I choose. I'm not going to derive for you the formula for an ellipse whose center is at the origin. However, I'm going to just give it to you. An ellipse that's elongated horizontally is going to have the equation x squared over a squared plus y squared over b squared equals 1, where a is the distance from the center to some outside point on the ellipse called a vertex, and this length here, because it's longer, it's called the major axis. B will be the distance from the center to another vertex, but it'll be shorter than the other one. This here is called the minor axis because it's the shorter one. Along the major axis, equidistant from the center, will be 2 points called the foci. And the foci, we're going to say that they are c units away from the center. And again, the foci lie on the major axis. We have a little equation for finding the length of the foci. It's c squared is equal to a squared minus b squared. This is not the Pythagorean theorem. I know it looks an awful lot like it, but it's not. So we're going to say that the foci, oops, don't do that, lie at negative c comma 0 and c comma 0. And we're going to say that these vertices on the major axis, which are the ones we really care about, lie at a0, and the other one will be over here and it lies at negative a0. If I change the orientation of the ellipse, so I elongate it vertically, this is going to change our problem a little bit, because the major axis is now this axis, and this is A from the center to this vertex. So the vertices must be at 0 comma A and 0 comma negative A. B is now this length on the minor axis, and the foci, I said, always lie on the major axis. So this time, if the foci are c units away from the center, we're going to say that they are at 0c and 0 negative c. This time we're going to say the equation of the ellipse is x squared over b squared plus y squared over a squared equals 1. Sometimes we reverse these two and we just write the y first. Really doesn't matter. Let's talk about sketching an ellipse and finding information from an equation of an ellipse. An ellipse has the equation x squared over 9 plus y squared over 4 equals 1. Find the foci, the vertices, and the lengths of the major and minor axes and sketch the graph. So this is what I want you to do when you look at an equation of an ellipse. Which fraction has the larger denominator? Is it the one under the x or the one under the y? Since the larger denominator is under x, I can tell you right off the bat that the ellipse is going to be elongated horizontally. When the larger value of the denominator is under y, it's going to be elongated vertically. Next, let's find the foci, vertices, and lengths of the major and minor axes before we go ahead and sketch this. So the foci, you need to know what C is. And in order to find C, we use this little formula. Well, from the equation, this is a squared and this is b squared. So c squared must be equal to 9 minus 4, which is 5, so c must be the square root of 5. So the foci must be at square root of 5, 0, and negative square root of 5, 0. Next, let's find the vertices. When you draw this ellipse, and the foci are here and here, the vertices, we only care about the ones on the major axis. So for an ellipse elongated horizontally, they are at a0 and negative a0. What's a? Well, since a squared is 9, a must be 3. So the vertices must be at 3, 0 and negative 3, 0. The length of the major axis is this length here. Well, if the vertices are at 3, 0 and negative 3, 0, that means that the major axis must be 6 units long. And the minor axis, well, let me use a different color here. This is b. And if b squared is 4, then b must be 2. So if that's 2, the other side must be 2. So the minor axis must be 4 units long. And so up at the top, I had drawn my sketch of what this would look like. I could have done a little more detail to this graph, but at least that sketch gives you a general idea of what it looks like. What if I wanted to put the equation of an ellipse in my graphing calculator so that I could see a picture? A lot of you probably have a conics graphing program somewhere in your applications. That's one way of doing it. But what if you just wanted to put the equation into y equals? Well, when you're dealing with an equation that looks like this, you already know that you can't put an equation into the calculator unless it says y equals something. So I'm literally going to solve this equation for y. I'm going to first subtract the x squared over 9, and then I'm going to multiply everything by 4, and then I'm going to square root everything. Well, when I do that, in order to see the full picture, when you square root, you've got to use that plus or minus symbol. So I would plug in positive square root of 4 minus 4x squared over 9 in y1 equals, and then I would put y2 equals negative square root of 4 minus 4x squared over 9. What you're doing is you're graphing two arcs, which when you see the whole entire picture together, you'll see the entire ellipse. Let's find the foci of an ellipse. Find the foci of the ellipse 16x squared plus 9y squared equals 144 and sketch its graph. Well, first of all, that equation doesn't look like the ellipse equation I just gave you. The ellipse equation I gave you was equal to 1 and not 144. I wonder what I could do to this equation so that I can make it equal to 1 instead of 144. Well, one guess you might have is to subtract 143 from both sides, but that won't make the equation look the way I want it to. I want this equation to have fractions in it. So the best way to deal with this is actually just divide everything by 144. Now, what you can do in your graphing calculator is you can reduce that fraction. If you put in 16 divided by 144 and then hit math, enter, enter, it'll tell you the answer is 1/9. So it's 1x squared over 9. 9 divided by 144 reduced is 1 over 16. So it's 1y squared over 16. And then 144 divided by 144 is 1. That's much better. Okay, so let's start with this. This has the larger denominator under the y. That means when I go to graph it, it's going to be elongated like this. There's my quick sketch. Now, because the major axis is the vertical length, this is a squared, so a must be 4. So I know 1, 2, 3, 4, 1, 2, 3, 4. That's how I can make my halfway decent sketch here. This must be b squared, so b must be 3. That means that I go 1, 2, 3 units to the right and 1, 2, 3 to the left. Well, I need to find the foci. Remember that we find the foci by doing c squared is equal to a squared minus b squared. So c squared must equal 16 minus 9. And 16 minus 9 is 7. So c must be the square root of 7. So the foci are at 0, comma, square root of 7 and 0, comma, negative square root of 7. Which is somewhere in here. Now let's work with some information and go backwards and write an equation of an ellipse. The vertices of an ellipse are at 4, 0 and negative 4, 0. I'm drawing myself a little sketch here. So the vertices are at 4, 0 and negative 4, 0. That means that the ellipse looks like this. So I know right off the bat that my equation is this form with a being under x. The foci are at 2, 0 and negative 2, 0. That means that c is 2. And a, we found out here, is 4. The only thing I don't know is b, so at least I know now that, let's see, I can get rid of this, and a squared is going to be 16. The only other thing I got to find out is what b is. Well, I can go back and use this equation to find b, because I know c is 2, so c squared is 4. A is 4, a squared is 16. When I subtract 16, I find out that negative 12 is equal to negative b squared, and those negatives cancel. So b squared is 12. I don't even have to take the square root, because I needed to know what b squared was. So now I can get rid of this b squared, and in its place I can put 12. And there's the equation and the sketch. One of the things you could probably figure out by drawing several ellipses yourself is that ellipses have different shapes. So this is an ellipse. This is an ellipse. This is an ellipse. And some ellipses are more elongated than others. That has to do with something called its eccentricity. When the eccentricity is close to 0, we'll call eccentricity E. If it's close to 0, then it's more circular. It's not quite a circle. A circle would be eccentricity of 0. And the closer it is to 1, it's very elongated, like in the third picture at the top. The eccentricity of an ellipse can be found by dividing C over A. And the eccentricity of an ellipse will always be a value between 0 and 1. This is kind of the same as probability. Probability is always a number that's between 0 and 1. Let's find the equation of an ellipse from its eccentricity and the foci. Find the equation of an ellipse with foci at 0, plus or minus 8, and eccentricity E equals 4/5, and sketch its graph. So the first question is this an ellipse that's really elongated or not so elongated? Well, remember, the closer that E is to 1, the more elongated or stretched out it is, and the closer it is to 0, the more circular it is. Well, 4/5 is awfully close to 1. Therefore, this is going to be an elongated ellipse. Next, is it elongated horizontally or vertically? Well, that depends on where the foci are. Remember, I said that the foci always lie on the major axis. So if the foci are at 0, 8, and 0, -8, that means that the ellipse looks like this. It's elongated vertically. Okay, so in order to write the equation, which in this case is going to be x squared over b squared plus y squared over a squared equals 1. Remember, we said that the eccentricity is c over a. So if a is 5, then a squared is 25. So now I can get rid of that and replace it with 25. Now I need to find out what... actually, let me scratch that for a second. Let me go back here for a second. I misspoke, as I often do. Actually, because the foci are at 8 and -8, that means C is 8. So 4/5, which is C over A, if C is 8, we actually have to solve this for A. Well, all you have to do is multiply the denominator by 2, and you find out A is 10. So actually, A squared here is 100. I'm sorry I misspoke. I need to be more careful about my work. Okay, now I can go find out what B squared is. Remember, the equation we use is C squared is equal to A squared minus B squared. So C squared is going to be 64 because C is 8. A squared is 100. 64 minus 100 is -36, and the negatives cancel, so we find out that B squared is 36. So now all I have to do is get rid of the B squared, replace it with 36, and there is the equation of my ellipse. And now I know that A is actually 10, so the vertices are at 0, 10, and 0, -10.